In this lesson, we are going to start graphing circles and ellipses. So the first thing is we're going to graph some circles and just kind of talk through and how you graph a circle is going to be pretty similar to how you graph an ellipse. There's going to be a certain form that we want to manipulate our equations into. This is our standard form for graphing a circle. I like to kind of refer to it as a graphing form. It's kind of like your y equals mx plus b in a linear equation kind of world, or it's like your, for quadratics, it's your vertex form. So that's the graphing form, just like these are the graphing form for quadratics and linears. Quadratics come in other forms, linears come in other forms, but if you're asked to graph, that's kind of the look that you want. So if it's not in this form, we'll have to manipulate it to get it into that form. But the first two examples are going to be in that form. So you have your vertex, which is the center, really, because it's called center of the circle. It's going to be your h and k, which is really similar to what you have for your quadratic. So there's going to be some similarities, just your shape and everything is going to be a little bit different, but there's definitely an overlap between the two. So this is going to be your left and right shift, this is going to be your up and down shift, and then since it's a circle, you're going a certain distance or in all your directions, which is in the equation. It's already kind of built in, but it's the radius squared. So you'll have to square root it to kind of get it out of there. So let's go through two examples real quick. So here is your x squared plus y squared equals 36. Your center is going to be, you don't have any plus or minus, so you don't have any left or right shift or up and down shift. So that means that your center is going to be at 0, 0. It is in standard form, so there's nothing for us to do. And then the only thing that we have to figure out is remembering that this value is an r squared value. So really your r squared equals 36. So we'll square root both sides. So your radius is 6. Technically I'm supposed to have a plus and a minus on here, but you're not going to have a negative radius. So it's just the radius is 6. So we have everything we need. So the radius is 6. So we're going to start off at 0, 0. And then the radius being 6 means we're going to be at a distance of 6. 1, 2, 3, 4, 5, 6. And you're going to constantly stay at a distance of 6. So 1, 2, 3, 4, 5, 6. So we'll go up and down 6. 1, 2, 3. And then left and right 6. And then do the best I can to actually draw a circle. Not bad. But that's it. So we need to find our center, and we need to basically find our radius so we can go kind of northeast, south, and west from our center. So if we look at the second example, this one does have a left and right shift, an up and down shift, and then our radius. So our radius squared is 4, because remember that that's an r squared value, and so we square root. So the radius is squared in the equation, which leaves us with 2 for our radius. And then we are right 3 and down 5. So just like in your quadratic, this is left and right, and when it's in parentheses, it's going to be in the opposite direction. So that has a similar feel for both of these. So this is going to be a right 3, so a positive 3, and this is going to be a down 5 because it's going to be a negative 5. So for your vertex or your center, you're looking at right 3, down 5. It is in standard form, aka graphing form. And then our radius is 2. So we have everything we need. So we'll go right 3, down 5, and then we go 2 in every direction. So a smaller circle. So then the idea of this graph, remember that, what is the point of the graph? Well, all of these points satisfy this equation. So if you were to plug in that coordinate of 1, negative 5, and you plugged a 1 here and a negative 5 here, if you did this math, it would add up to 4. Even if you were to take one of these points, if you could figure out what the coordinate is for it, and plug them into this and square them and add them together, it would also add up to 4. So all those points represent all the solutions to this equation, the points that satisfy that equation. radius of 2, not r. Okay, so that's the first two examples, and then the next two examples, they're not going to be in standard form, so we're going to be using completing the square to get them ready to graph.